Hi, my name is Alan March. I'm a Professor of Urban Planning and Disaster Risk Reduction at Melbourne University. And in this brief video recording, I'm going to look at the application of Australian Standard AS 3959 2018. And I will be talking about the application of this part of the building code. It's a foundational and I guess fundamental part of how we manage bushfire or wildfire risks in Australia using construction standards applied to structures. You may want to watch a video prior to this where I talk about the mapping that's used to guide how the regulations are applied. So this is going to be a very summarized version. There's all kinds of complexities and assumptions within a code like this, just as there always is. But in this one, I'll really just go through the fundamental parts of the method used and how it is applied without going into the detailed design elements. Of course, we have many significant fires in Australia over time. Here in Victoria, the one that has had the most impact in recent memory for most people, acknowledging there are other fires that have occurred, is the 2009 bushfires in Victoria, where we really started to appreciate, I believe, the importance of design and structural integrity of these buildings to reduce the chances of them being damaged or destroyed, and indeed playing a role in the protection of human life. The mapping for bushfire-prone areas is extensive across all of Australia, and in this case, the state of Victoria that I'm showing. Basically, if there's any bushfire risk, wildfire risk, it will be covered by the bushfire-prone areas mapping. And you can see, obviously, one of the most important places is an urban edge where there's an interaction, an interface with vegetation. So the code itself fits under the National Construction Code of Australia, whereby almost all structures that are built require a building permit to ensure safety and health of humans. You can see, if you can read that detail there, it started in 1991 and it's been updated over time. And I've just taken some screenshots of the code to draw attention to some key elements as I see it, so you can understand the basics of this code. The main thing it does, it specifies a construction standard according to the nature or the intensity of the wildfire risk in that particular location. There is an assumption that it will not necessarily protect the structure from eventual destruction. However, the other assumption alongside that that's implicit is that the application of these regulations will significantly improve the chances of that building performing better under wildfire attack conditions. So the main thing in the objectives is that the standard seeks to establish a construction standard that relates to the nature of the fire attack that will occur in a particular location. And a cornerstone of this establishment of the appropriate construction standard is determining the bushfire attack level that is likely to occur for a structure in a particular location. This is expressed as bushfire attack level. We just call them BALs for short, and it's kilowatts per metre squared on a structure, on its surface essentially. But within that are assumptions about the potential for ember attack and in some cases direct flame contact. So there's a relatively simple decision tree by which the BAL levels, you can see here, they're successively increasing. Relatively simple decision tree that frames the application, and determining which BAL applies to a given structure. These are categorized. It's not a sliding scale in the simplified method. Certain construction standards are applied, construction standards in section 3 apply right throughout, and then 5, 6, 7, 8, 9 apply on a successively higher intensity of expected wildfire attack. So the essence of the method is captured on this slide, and I'll go through these fairly briefly with the assumption that we can fill in the detail of certain elements in successive videos by myself and indeed by others. So there are these 6 main steps. A fire danger index is worked out. That's essentially understanding the nature of the potentially worst fire, you could say, that could occur in a particular location according to weather, vegetation, slopes, and so forth. What is the vegetation that might carry a fire in a location? Distance of a structure from that vegetation. What's the slope under that vegetation, and then come up with a BAL, and then work out what construction standards apply on that location. So very much a regulator's way through it, I suppose. And as you'll see in this simplified method, very much categorization driven, not looking at necessarily the nuances or a sliding scale approach. Very broad brush understandings of the fire danger index are applied, although there are opportunities to modify these on a site-by-site basis according to the jurisdiction that you're in. Then, just in an elevation or profile view, we might have a house as the structure. We would then determine what this vegetation is. In this case, it's been determined as forest. I'll talk about those classifications in a moment. Then we would determine the slope underneath the particular vegetation we're looking at in that instance, the distance to the edge of that vegetation type. And you'll notice that the distances are all horizontal in this method. And then that generates an understanding of the bushfire attack level from that particular bit of vegetation. Now, this is on the assumption that, of course, most sites will have potentially a few different types of vegetation with a particular slope under them that will deliver a BAL. And what we do is work them all out, and then we determine the highest BAL, and that's the one that is applied to the structure. We have an understanding in this simplified method that we measure the slopes as if we've got our back to the potential structure that might be built, and we would call that an upslope. And in this simplified method, we ignore the slope underneath the space between, and we're only working out the slope under the vegetation that is being considered, because that's going to influence the behaviour of a fire if it were to approach this structure. So this, we call that an upslope, and we assume that that is the same as flat land, because if the fire were advancing down here, obviously its speed would be much less because it's going in a downwards direction towards the structure. So if we were, by contrast, to look at this one, we would be calling that a downslope. And obviously with fire behaviour, this is potentially much more dangerous because the fire will move more quickly, therefore burning the fuels much more hotly and quickly, and so much more energy being expended on the face of this structure. So as you will see, the calculations take into account those different slopes. So before going to the slope calculations, there's a set of categorizations of the different types of vegetation in Australia. Obviously, this is a very broad brush approach in this simplified method, where we make a series of assumptions, and these are the classifications down the side, acknowledging that they include many different types of vegetation, subclasses, you might say, within these broad categorizations of veg classification. You can see there are many more types that we categorize, including grassland. So then with those inputs in this simplified method, we would then say, okay, for example, we've got forest. It's on the forest we're classifying in that particular instance is on flat land or an upslope. And we might say, oh, it's 20 meters from the proposed structure we're going to build. That falls into this category of 19 to 25 meters from the edge of the structure. And that would put it into this category that any structure built on that land with that vegetation and the slope under that vegetation would result in a bushfire attack level of 40 kilowatts meters squared. And then the subsequent structure would need to be able to handle BAL 40 conditions. And as you probably worked out just from looking at this, different vegetation will give different outcomes for the BAL and indeed for different slopes underneath that vegetation. So essentially we successfully go through the different BAL responses that we would get for a site in a location according to the slope and vegetation, the slope underneath the various classified vegetations. And we are required by the building code to meet the construction standards of the highest BAL that is delivered by that systematic analysis. And you can see the kinds of BAL outcomes you get and the distances you need as we get to down slopes, the dangerous slopes up to 20 degrees. Much greater separation distances are required to allow construction just because the intensity of the bushfire attack is so much greater for, say, forest with a lot of slope underneath it heading towards a given construction site. So just reiterating, we move through this process where we work out that BAL level, and then say we get to BAL 19, it means then you need to meet a construction standard set out in AS 3959, the code that has section 3, which is generic and it applies to every single one of the construction standards, and then the particular BAL 19 construction standards set out in section 6, and you can see they apply as you move through these different intensities of likely bushfire attack level. So just the Country Fire Authority produced this really good diagram some time ago, just to illustrate that in a slightly easier to understand format. So under BAL 12.5, starting to have some radiant heat, but definitely trying to take into account ember attack. Throughout all of these categorizations, ember attack is taken care of. That yields a lot of value because we know now ember attack is one of the most dangerous aspects of fire that can be dealt with relatively easily with use of screening and stopping underfloor fires and things like that. And then we get to BAL 29, there's starting to be the potential for direct flame contact. BAL 40, we're starting to get pretty dangerous here, of course. Lots of ember attack, windborne debris, radiant heat between 29 and 40 kilowatts meters squared, likely exposure from flames. And then flame zone, we're imagining here that the structure might be enveloped by flame or lots of direct flame contact. Obviously, we would avoid putting structures in such a location if we could. Then, say if we look at some of the aspects of section 3 that apply across the different BAL levels, one of the most important ones, making sure vents, weep holes, joints and the like, they have to be screened. And those screens less than 3 millimeters or 2 millimeters, depending on the application, to stop embers going in. And this leads me to one of the other assumptions of this building code is that this is a timber construction code for wooden frame structures on the whole. And there's an assumption that we try and keep the envelope tight to prevent the entry of embers. And I guess that's one of that assumption is also perhaps a failing that once the structure fails in some ways and embers can get inside, there's a much greater likelihood of the structure failing. So think a lot of stuff about gaps between structures and avoiding the embers entering the structure. Standards around door framing and window framing. And then we go to, you know, a BAL 19 structural standard. How is the floor made? You know, are they enclosed subfloor spaces? What is the wall system that's going to be used, and how will that prevent ember attack and have the correct building materials that can withstand the kind of heat attack, the radiant heat flux that's expected at BAL 19 levels. External windows, the window systems we know are often one of the first points to fail in a fire event. So there's a series of standards that are set according to the BAL level. Roof systems, gutters, sarking, you know, how different roof systems are required to be set up so they avoid ember attack and failure under bushfire attack. Verandas, decks and landings, again, we know they're one of the weak points often in bushfire events. So that brings me to a close, fairly brief summary of what admittedly is a very complex area, and a few notes to close with. As I said, this is the code for wooden frame structures. The reason for that is it's a very common technique in Australia to build in that way. There's also the NASH standard, which uses the same method but specifies steel frame construction techniques. And obviously, some of the assumptions in this are that the structure is not necessarily going to withstand every single fire that might occur, but it will significantly improve its performance and hopefully to protect the humans within, even if the structure eventually does fail. The last thing I'll mention is that this code also includes what's known as method 2, alternative methods, where you can go back to the fundamental science and have much more detailed inputs that takes you outside those broad categorizations. Much more complex and requires considerably greater care in its application because of the nature of the calculations required. So I hope that very brief summary whets your appetite and starts to demystify some aspects of Australian Standard AS 3959, building in bushfire-prone areas. Thank you. Have a great day.